So I'll try to wrap it up in few minutes and then leaving a little bit time for discussion afterwards. Basically, the idea of this webinar is also to give you an overview of the actions that are going on with respect to the research on sleep quality. This is the bedroom is one of the environments that has been actually researched very little. And in the last 5, maybe 7 years, there is more and more focus on that particular environment where we spend most of our very important part of our life, and which is crucial actually for our functioning, normal functioning, our health, and so on and so on. So I have a pleasure to say a few words about the project that actually we received from actually were granted by ASHRAE, American Society of Heating, Refrigeration and Air Conditioning Engineers, in 2019, after many years of attempting to apply for the project. The project title is The Effects of Ventilation in Sleeping Environments, and you can guess that basically the main purpose here is to understand the role of ventilation in the sleeping environment. And how it is done, I will tell you in a moment. A few details about the project. So the two co-principal investigators of the project is Professor Li Lan from Shanghai Jiao Tong University, that was speaking earlier, and myself from the Technical University of Denmark. So the project was launched in 2019, and of course, we were working during pandemic time. Fortunately, that only affected very little our research. But basically, it caused that the research was a little bit, we have some delays, but actually also we generated a lot of data that needs to be analyzed. So we extended the final delivery of the project report to actually summer this year. The funding that we received from ASHRAE was around 230,000 US dollars, but actually we invested much more, and probably the total amount would be closer to about 400, so double the amount. So far we published 13 papers. I don't have a list here. I can send them later for those who are interested, and there will be probably around 7 to 10 other papers coming as a result of this project. Basically what we promised, what 4 tasks is to provide a summary of standards defining bedroom conditions, summary of literature on ventilation and sleep quality. That has been partially presented by Professor Chandrasekhar in the beginning. Then we promised cross-sectional studies in bedrooms to characterize ventilation conditions, and then also we promised intervention studies in bedrooms. So basically very simple protocol to understand the importance of ventilation. And our overall objective was to basically amend the standards on ventilation that, as Professor Sekhar mentioned, do not include specific information for bedrooms with few exceptions. So residential environments are considered as basically one big volume in which we need to provide ventilation. The question is that ventilation sufficient for our sleeping, proper sleeping, and then or high quality sleeping, or whether it needs to be, how to say, revised. One important element of the entire project was that we did not want to run the project only in one specific region of the world with one specific climate. So the idea came from Denmark. Of course, this is our base here with a temperate climate and specific type of course, construction and building residential buildings. But from the very beginning, we were thinking that we need to involve another partner that is coming from another part of the world and where there is a different climate. This is why we joined the forces together with Jiao Tong University, so that to cover that aspect. So The work that I will be presenting today, some of the work that was done at our university in Denmark, and some of it that was done in China. Basically, what was happening, we were copying basically the studies, so they were done in parallel, both in Denmark and in China, or basically in two regions of the world, in order to be able to extend their applicability, and also to look at any differences that may occur and try to understand those differences, and of course look at the similarities. But unfortunately, working in a group like this, or maybe fortunately, there's a lot of good ideas, and we try to squeeze a little bit funding to be able to do other research as well. We thought that there is a lot of research that needs to be done along in order to be able to get to the main objective. So basically, we extended the research program by additional studies. And one of the studies that we looked at was the basically look at how COVID-19 lockdown affected the sleep quality and the bedroom conditions. Also, we performed laboratory studies. So the idea, of course, of doing the work on sleep in laboratory may be controversial in a sense that, in the lab studies, you can actually measure very carefully the sleep quality, but at the same time, this is not the normal place where we sleep. So there may be some negative effects of that. But nevertheless, we decided to look at some studies because of many reasons. And one of the reasons was to understand the impact of ventilation and also impact of pure CO2. CO2 is now used as a marker of ventilation, but the question is, would CO2 as in itself have an effect on our sleep quality? Also temperature, ventilation, noise on sleep quality. Furthermore, in those studies, we were looking at how much CO2 we emit when we sleep. This is an important parameter that needs to be known in order to determine ventilation rates in bedrooms. And also recently, just actually a month ago, we completed a very long campaign in which we measured the emission rates of bioeffluents from sleeping people. This is the information that completely does not exist in the literature. So we have that as well. Also, we extended the research, not only looking at the ventilation in terms of engineering the design ventilation, but also look at behavior of human. Normally, when there is no ventilation or at all, people either open bedroom doors or windows. So the question is whether that would have any effect on sleep quality. And finally, to measure sleep quality, and that would require a completely different lecture here or presentation, is a very complicated task. And usually polysomnographs are used. And those polysomnographs, even if they are portable, they are extremely expensive. So today we use activity watches or so-called sleep trackers to do that. So we wanted to understand how well they can actually provide us information in comparison with the information on sleep quality that is provided by polysomnographs. So some of this work has been already reported, some of it is in preparation. So during this year, actually, when we will be completing the study, we will be publishing the work on all the aspects that you will see here. Perhaps the results from the emission rates of bioeffluents from sleeping people, I'm not sure when they are going to be published. We need to have a very good expertise, but we have data on it. So that needs to be analyzed. So quickly about some of the results, just to very, very brief summary of that. So Professor Sekar already told you about the review of literature and standards on the measurements of ventilation in bedrooms. And in many presentations, we saw that bedrooms can be actually have too high temperatures, basically too low ventilation, usually naturally ventilated bedrooms, bedrooms with air conditioning. During the heating season, this is the critical moments for where the conditions can be changed. But of course, the question was at the very beginning of the project, do we know anything about ventilation and sleep quality? So what we did is we identify studies and that actually provide any information on any relation between any type of measurement that was done on sleep quality and measurements of ventilation. And that we identified, as you can see here, there are 7 dots, but these are 6 studies which reported levels or some means of intervention to the bedrooms and measures of sleep quality. And created a tentative relationship between ventilation expressed as the level of CO2 in the bedroom and some way of measuring sleep quality. I don't have time to explain how the sleep quality is measured and was measured in those studies, and may not be comparable across the different studies, but nevertheless, that is published in ASHRAE journal in April 2021 for those who really would like to study that. The most important observation was that at the levels of CO2 below 700-800 ppm, there is a so-called undisturbed sleep quality. We were not able to find any studies that show that there would be any effects. And the levels above 2,600 ppm CO2, so ventilation that is resulting in that high levels of CO2, would cause that we have disturbed sleep quality, and the next day we perform less well. Above level of around 1100 to 1200 ppm, there is disturbed sleep quality. Between 800 and 1200 ppm, it's sometimes there may be disturbed sleep quality, so it's and sometimes there is no effect. So it's unknown territory, unknown region. So this is about the literature survey. And so we had that tentative relationship, and our idea was to look at whether we can confirm through the studies. So first we started with laboratory experiments. So we don't have so laboratory experiments can be done either in the bedrooms or rooms that are basically a mock-up of the bedroom, or we can do the measurements in the chambers. And in order to create the conditions that can be quickly monitored and quickly steady-state concentrations can be obtained, we actually built a sleeping capsule that is presented here, and those sleeping capsules are actually present in our stainless steel chambers. And the studies were done both in the mock-up of the bedrooms and the sleeping capsules. So one of the studies that we performed was the estimation of the emission rate of CO2. That for the young adults, we observed that independently of the conditions that you sleep, actually they are around 11 liters per hour per person during the night. This is 40% lower for the emission rates for the people who are awake. And they are fairly constant across different studies. I don't have here results, but for elderly, we found a little bit lower emission rates that changed with the increased temperature because of the going into the light sleep stage. And also there is an unpublished work from the other group in Denmark that shows that those levels are very similar for children at the school age. So from this level, we can then of emission rate, we can now convert the 800 ppm into ventilation rate, and then we find out that ventilation rate of 10 liters per second per person would be best to avoid disturbance to sleep in our bedrooms per person. What we did also was we looked at the effects of ventilation and temperature on sleep quality in the sleeping capsule. Remember, these are the capsules in which people sleep for one night. They need to adapt to sleeping in these capsules and so on. But what we found out that both through the results in those measurements, that both the temperature and reduced increased temperature and reduced ventilation have negative effects on sleep. They disturb the sleep by basically causing the increased latency of sleep. So it takes more time to fall asleep when the temperature is too high or ventilation is poor. In China, additionally, the measurements were done in order to look in the mock-up of the bedroom to look at the effects of ventilation and ventilation noise on sleep quality. And as you would expect, the results indicated that ventilation noise should be avoided. And this is a very important observation, quite obvious and trivial, but confirming that noise, of course, is a very significant aspect. But of course, ventilation effects, positive effects of ventilation can be cancelled out if the noise from the ventilation exists. Then we performed a range of field experiments, and then we made several types of approaches here, starting with the surveys, going through cross-sectional and intervention studies. So this is a study that Jelle has actually presented earlier, in which we surveyed more than 500 Danish bedrooms. Similar survey was done in China. I will show in a moment results. Basically, we did it during the heating season in China, was both heating and cooling season, or maybe summer and winter time. And basically what we found out that in case the mechanical ventilation was present in bedroom, then the number of disturbances to sleep quality is reduced, except for the other findings that Jelle has already presented. Then what we did is we used the same pool of people, because after that survey, the first lockdown was happening in Denmark. And then we actually contacted the people again after the second lockdown to find out whether there are any changes to their sleep patterns because of the lockdown. And the most important takeaways from this study is that basically many people converted bedrooms to offices. There was increased ventilation in bedrooms, and but around 33% felt that their sleep quality decreased. What are the reasons for that? But it's we don't know, but it's a natural experiment that is worth investigating. And then we repeated the studies, of course, in China, and this is exactly, we found that again, the similar findings as in Denmark is basically heat, cold, noise, and dryness and noise were affecting sleep quality as assessed or rated by the occupants of the buildings. Then we performed the measurements. So this is a survey. So we ask people, they provide us information, and we made measurements. For that purpose, we developed a unit that contained a measuring instrumentation, including the sleep tracker and also the temperature sensor measuring the wrist temperature. And also we developed an online diary to collect information from the participants of those studies. And then we performed cross-sectional studies, both in China and in Denmark, in which we find out that these were a week long, when during a week we measured the conditions in bedrooms and also sleep quality, and we found out that sleeping with either windows or doors open was associated with improved subjectively rated sleep quality, so as rated by people. And then there were some indications of the potential mechanisms in relation to poorer quality. And in China, we found out that that there was effects on the deep sleep of elevated temperatures and reduced ventilation. And all of this is published. Then we continued with the intervention studies, both in Denmark and in China, and this is one of them that is published here. We have now actually in progress 2 papers that present 2 other intervention studies, both in China and in Denmark. And in this study, what we observed was that we looked at the impact of window door opening in bedrooms. And what we found is that bedroom door and window opening will reduce the level of CO2, but only window opening in Denmark will have a positive effect on sleep quality. Meaning that, and also perceived air quality. So the air quality is perceived better and the sleep quality is improved. In China, there are slightly different results because they were done in during the heating season. And basically what they observed is also that there was some cancelling of the positive effect of opening the window because of the pollution from outside and the heat from the outside. So what we can conclude so far, briefly, if you want to go home today and you want to do something about your bedroom, so make sure that there is adequate bedroom ventilation. And of course, we believe that the ventilation standards require revisions to focus on bedroom ventilation. So the bedroom has to have a specific role in our residential environment. We also believe, but it's a digression, is that also kitchens and living room has to have a special, or open kitchen has to have a special. But anyway, we focus now on bedrooms. So then, if you want to check whether your ventilation is adequate, remember, it's you have to make sure that you ventilate with the open window. Keep CO2 below 700-800 ppm. This is best. Minimum 1100-1200. Use outdoor air. Door opening to bedroom brings little or no benefit to sleep quality. If you have a ventilation, make sure that it's quiet, and if you have it, measure that it's delivering 10 liters per second per person, independently of age. So basically, it seems like there is a little difference, but that has to be confirmed. It's a tentative. If you convert your bedroom to a storage room or the office, make sure that you have even higher ventilation. You should avoid sources of pollution in bedrooms because we, through our surveys, showed that basically the more sources, the more disturbance to sleep. Avoid elevated temperature. It is difficult to fall asleep and to stay asleep when the bedroom is too hot. That is obvious, of course. And then there is no single temperature that is ideal at all stages of night. Basically, lower temperatures will have a beneficial effect. We still don't know the quantitative effect on next day performance. There are some attempts to economize this, but I believe that we are only in the beginning of the entire process to better understand that and put some economic value on this. So I would like to recognize all our WC team as a world champion team, I call it, because it's 20 people, 21 people, so it's nearly like a football team or soccer team. There is 22 players. So I would like to, if I miss someone, please excuse me. I will add, of course, on the list, but this is all the people thanks to whom actually all the research was available and possible. Thanks. We are 3 minutes behind the schedule, but thank you for staying with us. And then I will be happy to answer questions if there are any. Thanks a lot.